So again, I mean, Collage is just measuring this thing. It's measuring the execution, and in this case, it might throw, it might not. I'd like to go in a bit of code with you all. Collage lets you just write code. Pretty much everything that goes in normal code goes here. The only thing Collage actually knows is that you can go to a certain amount of users. I feel very inspired, so I'm going to go to 3 users. And maybe you've noticed that I didn't say anything about time. How long does this test run? Collage has an event loop. It's actually super simple. Collage is 250 lines of code, the whole thing. Users allows you to describe users over time. Okay, so go to 3. Well, you go to 3. Let's say we want to have this test run for a minute, and you make sure this function sleeps for a minute. And you've just told Collage, I want 3 users. So let's say you're running a test, you want 1,000 users per second, and at some point in time, there are still 10 busy when the next tick comes. So what does this mean? If the performance test thing is proper, it means that something out there is giving you back pressure. It's that simple. So something there is preventing you from moving ahead. So if you can measure that you're not able to run that much users anymore, you'll know probably that your system is failing to deliver. So this is what I said we created the traffic function. So there's another thing, which is ramp. So let's say I'm gonna ramp to the target, 100, in this duration. So basically what Collage does is it says, okay, you are at 3, you wanna go to 100. The last number you see is always where it's gonna end up. So then of course you have the thing that those users are going to do. So let's start off with writing a test. So scenario, actually, if you look at the block, I'm not sure everybody can read it, but it's actually an extension function on user. Because here you're gonna describe what a user does. So what's the user gonna do? It's gonna perform an action, whatever. It's gonna click a button. Of course, we wanna do stuff asynchronously. Well, we are coroutine land, so it's not that we wanna do stuff asynchronously or non-blocking. We wanna never ever do something blocking. If you start using REST template in here, the whole thing dies. Mostly also the tests that we run them with 1 core and 1 gigabyte of memory. That's the workers that we utilize. So we have 1 thread. It's really easy because you have 0 concurrency overhead. And again, that makes it simple. And then we scale horizontally, which makes it also really simple because you have no controller. Let's just say go to 50 and hold that. With test, it has this one scenario. I'll go into how you can do different things. And that has this action. So again, I mean, Collage is just measuring this thing. It's measuring the execution of this lambda. And in this case, it might throw, it might not. So let's see if we got some stuff here. Yay! So, well, it seems that sometimes it's failing. Also, here's the ticker. It ticks every second. It has ticks and it has skips. If you start seeing skips, something there is probably not working out. So you see here we have virtual users. No ramp up just started. We're going to the 5th scenario, so it's about halfway up, right? Random, like halfway is true, halfway is false. This is the throughput per second. The latency is below a microsecond. So that's just execution time and the Kotlin coroutine runtime, because coroutines are definitely not for free. So we have a plugin called Web Client, and it gives you an actual web client. Web client is actually an extension on user, and action is the thing that measures errors, right? So you can see that here we actually call action and forward the name that we've passed to it. A web client is just a wrapper around an action that you perform with web client. So let's see what that does, because we saw that how this was working out. So I think, yeah, so this all of a sudden had latency. So the 99.5 latency was this. So it gives you these percentiles, gives you the error margin. And of course, currently we are no longer given error. So this localhost 1990 is, by the way, where Prometheus lives. So I'll use this as an example. So you see that it starts, it actually does something. But you have JIT compilation, so it will get faster and faster. It usually ends up at like 3 to 4 milliseconds. Throughput is slowly going up. You have a bit more metrics here. You can actually see how many, what the CPU does. Well, this is interesting. If you're running it in the cloud, then you probably want to know how much CPU you're using. So is the skipping that I observed due to my machine being throttled or being fully utilized? So this is why you also need to take into account your actual resources yourself. So if it skips, check if you're the bottleneck by looking at the resources. If not, that's probably the other thing that you're testing. So sometimes you want to do something with a user. So why do you want to have this on the scope? Well, let's say you're dynamically fetching data, right? So this scenario is running, being ran by 50 users. So you can't just say, I'm going to create a list here, and then I'm going to get a user from that list. So because it's running concurrently, your data structure needs to be concurrently. So let's see. So I'm running out of time here. There's so much to tell. So if you do this, you get a receive channel that gives you an int. So you could do now here. And this is how you would actually, so this could be just a file that you read, right? Well, not entirely. Let's imagine this. You have one file, 20 workers running, and that file contains user accounts. And then all of them 20 start at index 0. And all of them 20 start to log in as user 8. That's completely messed up. But you don't have that in Collage because it focuses on a single node. However, you need to solve this problem if you start running distributed. So we have a Collage K8, which is basically a piece of Java code that you use to start Collage in the cloud, and you tell it the number of workers. And it spins up your Collage pods, it waits for them to all die, and then it goes down. So it's basically a controller, but it doesn't interact with any of these pods. These pods don't know, but it is the parent. Why is that? Because I want to kill my 100 running workers at once by killing the parent. So Kubernetes has a concept of a parent job. So this is why we create one parent job that spins up all the workers so we can kill all the workers. Plus, if I do another deployment of my test, I want that deployment to kill the old one and start a new one. So this is why you need that kind of a mechanism. So what does it do? Well, if it spins up, every worker, as you know, gets told by an environment variable how many workers there are and what its index is. So it can actually do a modulo operation on the index of the line in the file, and it can give every node its own user from that list of users. And to prevent any issues, so you don't need an eternally long list, it will automatically, in editors it's line wrapping, but it will just start at the beginning and it will start. So basically what happens is one node reuses the same kind of workers, just like if you would locally, that single node would use all the workers and start from the go. I could talk a lot more, but I'm afraid I ran out of time. So yeah, I'm pretty happy with it. Thanks for taking the time to listen to it, and that's it.